All right, hi everyone, welcome back. Here I have an assignment problem for you with a little bit of a twist. I'd really like you to pause the video after we go over what the problem actually is and try this one on your own. You'll see, like anything, even though we create initial templates, there's always something later that needs to be adjusted, that needs to be taken care of. All right, so here we go. In this example, our job is to assign one umpire crew to each city. We have crews that are currently in Seattle, Arlington, Oakland, and Baltimore. And they need to go to the next game at Kansas City, Chicago, Detroit, or Toronto. Now, you can only take one crew and assign them to one city. So you should not send two crews to the same city. So one crew per city. You also want to minimize the total distance traveled. So you want to do this in the most efficient way possible. Now, baseball has a lot of unions, and there's a union requirement here that you are not allowed to send any crew from Oakland to Toronto. That is too far to fly, just not allowed. It's one of these constraints that you just have to follow. So if you want, pause the video now and try to find the optimal solution. Look up your old templates, pretend it's a little quiz, pause the video and do it, and see if you match me at the end of the video, if you can do this. There is a little catch in here. I have the distances in miles between each city. That is always given. And of course, the X marks the spot here between Oakland and Toronto. That is saying that you cannot fly someone from Oakland to Toronto. All right, pause the video if you haven't done so and try to work this out. Ready? What do we do? So once we have our cost table, now here notice cost is in distance and miles, we copy the table, the whole thing, paste it again, and we clear out the costs, and we turn the cells green. These are going to be the answers. This is going to be our decision variables. We're going to want all these numbers to be zeros and ones. We can put some dummy numbers in here just to see what happens. A 1, of course, means yes, send the Seattle crew to Kansas City, and then blanks or zeros mean no. We must keep track of how many cities these crews were getting sent to. So let's create a total column and sum up the row. And we'll drag that formula down. Just summing the row. One more time, I'll click it for you so you can see what's going on. And I want this, remember what is bad here, I don't want it to be 0. I would say that the Seattle crew doesn't get assigned anywhere. And I certainly don't want something like this to happen where I have a 1 in 2 different spots that says send the Seattle crew to both Kansas City and to Toronto. That can't happen. So whatever this total is, the right answer, the correct answer, then this number would actually be equal. I get the equal sign just to show, to remind you, we're going to use a single apostrophe and then type equal. That's Excel's way of saying this is not a formula. You truly do want text. And this number 1 is just a number 1. It is also not a formula. The formula that comes in are in column F. I will drag down the dollar signs and the ones across the board. Now I want to do the same thing for my totals for my columns of this table. I will sum down the column from B13 to B16. This will keep track how many crews are being sent to Kansas City. I'm trying to avoid here is a 1 and then another 1 in the column. Again, what do these numbers mean? It says send the Seattle crew to Kansas City and send the Baltimore crew to Kansas City, and now you have 2 umpiring crews that are showing up at the same stadium, and of course, that's just going to mess things up, so we don't want that. So we have our sum across the board, and I drag this across. To keep track of all the sums. So there's lots of badness going on here. Obviously, this is just a dummy answers to make sure the spreadsheet's working, but it certainly seems like it is. And once again, I really want this to be, I could have it equal to 1, or I could even do less than or equal to 1. It'll all work out just fine. Which one you want, less than or equal to 1. But this is how we're going to tell Solver to meet our constraint. Hopefully you got pretty close to this while you were working this out. The last thing to include is your objective. What's our objective going to be? We want to minimize the total distance. So again, I like to write up in my objective label what I'm actually doing. Do I want to minimize or maximize? And what am I actually minimizing? It's not a cost here. It's actually a distance in miles, of course. And we will color code this cell. All right, how do we do this? This is the same as before. So we'll do equals sum product. We highlight all of our costs, comma, and we highlight all of our variable cells, close the parentheses, and hit enter. I'll show this formula off on the side using the formula text function. And my distance in miles is 7750 based on these dummy numbers. So if you play around with the dummy numbers, hopefully this should update, and it does. This is where you can try by hand to guess or use your intuition at what the right answer should be. As I check things over, I realize I copied 1, 2, 3, 4. Let's fix that. These should all equal 1 in column H. Once we're happy with our spreadsheet, we head over to Solver. As usual, we set our objective to the gray cell. For me, it's in B22. We want to minimize the distance traveled in miles, and we set our variable cells. These are always the green ones, so we highlight the entire box of green cells. We have a couple constraints here. The first one being that only one crew can be sent to one city, so we'll batch upload these. This is me selecting all of F, and that should equal 1. You can highlight the ones or you can just type it, that's okay. Let's add another constraint. I want to make sure that each city only receives one crew. Highlight all the cities, and I can select equal, and then once again, or I can even do less than equal, doesn't matter, but you can select the one or type it, it's all going to work, and hit OK. So once again, you have your sort of supply and demand. Make sure the box is checked to make unconstrained variables non-negative. Select simplex LP. Solver found a solution. Thank you, Solver. We hit OK. And now let's take a look at our solution. I was able to do this with 2,590. So this is it. This is fantastic, right? Seattle goes to Chicago, Arlington to Kansas City, Oakland will go to Toronto. Wait a minute. As a reminder, Oakland's not allowed to go to Toronto. So if you found this answer, you kind of fell for a little bit of a trap here. What's happening in this one? Yes, this is the optimal solution. The problem is this X in the given, Excel is not treating that as a number, it's treating it as 0. So the cost to send the crew from Oakland to Toronto is 0. That's amazing, right? There's no cost to do that, so of course it's going to be selected when you're trying to minimize the distance. So what you have to do here, there's a couple ways to do it. Probably the easiest way to do it is treat it as a constraint. I can't send Oakland to Toronto, so why don't we add one more constraint and say, hey, look, this cell right here, for me, E15, the cell that assigns Oakland to Toronto, well, this has to equal 0. There's no way that cell's allowed to be 1. I don't care what else you do, but that cell must be 0. That's one way to do it. And now when I run Solver, I have a new solution. Seattle is being sent to Detroit, Arlington to Chicago, Oakland to Kansas City, that's perfectly fine, it's not to Toronto, and then Baltimore gets sent to Toronto. So each row has a 1 in it, each column has only one 1 in it, so this is the final assignment, and I would write that up for my summary sentence. The total distance, the minimal total distance, the best solution meeting this requirement that Oakland cannot go to Toronto is 4,580 miles. So watch out for that little X there. That's the sort of trap. If you didn't fall for it, give yourself a little pat on the shoulder. Nice job here. The final answer for us is 4,580. So feel free to go back into Solver and make any adjustments as needed. You can put as many constraints in here as it will allow. Always make sure you meet all constraints. All right, great job on this example. I will see you next time.